Hello chemistry students, welcome to Horace chemistry class. Today I will be teaching you how to do Lewis structures. What is that exactly? Lewis structure is bonds between molecules, two molecules, and molecules to lone pairs. Let me give you an example. Here we have the atom, the molecule CO2. What's that? Carbon dioxide. Here we have one carbon and two oxygen, CO2. Okay, how do you search that? First, the molecule that always goes in the center is the one that's always most electronegative. 9 out of 10 of the time, that's going to be carbon. So let's get carbon. If not, you can easily find out by looking at your periodic table from going from left to right. The further right you go, the more electronegative you are. The further to the bottom you go, the less electronegative you are. Okay, so carbon, center atom, okay? Let me just erase this here real quick. Give me one quick second. There we go. Okay, then how do you start? First, you gotta know what becomes two electrons. Okay, so carbon. You start off with carbon because carbon is the most electronegative, so it's gonna be in the middle. Next step, you gotta find out how many electrons each element has in the molecule. So how do we do that? Well, you look at that electron groups or the columns of the periodic table. You know, how the first one is 1, 2, you skip the middle, 3, 4, 5, 6, 7, 8. Yeah, example. Carbon is located in the 4th electron group or column, so that will be four electrons for carbon. Oxygen is located in the 6th, so that will be 6 electrons for oxygen, but there's 2 oxygen elements or atoms, so it will be a total of 12. Right? So you got 4 and 12. You add them up to get a total of 16. So you have 16 electrons to play with here. And exactly what do you mean by I say play with? Well, let me show you what I mean when I say play with. When I say play with, I mean, boom, one carbon, the center atom, and then you connect each oxygen to the carbon with a single bond. Now each single bond is 2 electrons. So we have 2 here, so you can take 4 electrons out of this 16 and you're left with 12. So now you have 12 electrons to spread across these oxygen and this carbon. Now, you must always remember the octet rule. My spelling is horrible, so don't judge me, but octet rule. What does that mean? That each atom in this molecule has to have 8 electrons. 8 electrons covering it, around it. The only exception of this rule is hydrogen. Hydrogen does not need to have any electrons around it. None. Now, what does this single bond mean? This single bond means that oxygen and carbon are sharing 2 electrons. Because remember, a single bond equals 2 electrons. So that means oxygen and carbon are sharing 2 electrons. So right now, oxygen and carbon, that's each of them have 2. This oxygen has 2, and they're sharing. So carbon so far has a total of 4 electrons. Oxygen has 2, and then the other oxygen has 2. Because remember, single bond, 2 electrons. Okay. Sorry, please excuse my handwriting. Now, so far you have, like I said, 4. 1, 2, 2, 4 electrons that are being used up. You have 12 to play with. Like I said, remember, the center atom always has to be filled first. So, boom, 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 boom. You might ask, what are these dots? These dots are called lone pairs. Lone pairs. What are lone pairs? Lone pairs are a set of 2 electrons, like you saw on the dots, not connected. Not a single bond, not a double bond, triple bond. It's just a set of 2 electrons. So now I have 4 more I used up. So that's take 4 off that. What are you left with? Anyone? Can anyone answer? Anyone? That's right, Jimmy. You're left with 8. 8 electrons. Okay. So now you got 8 electrons to play with, which is pretty good actually. So that looks like an infinity sign. Let me erase that real quick, make it a little better. 8. It's a little bit better. Now, you start filling out your outside. Just put dots, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So now you have, now let's count them. Now each atom has 8 electrons. Carbon has two sets of lone pairs, that's 4, plus a single bond, it's sharing 2 electrons with each oxygen, that's 4 more, that's 8. Now, oxygen. So far, now we got into the problem that we have 16 electrons to give, but there was a total of 20 electrons that we used. Remember, CO2, that molecule itself only has 16 electrons spread between the two. So how do you fix this? Well, where a single bond is it's 2 electrons, meaning electrons, again, excuse my handwriting. Single bond, that means that that's a single bond right there, one little line. That means the C and the O are sharing 2 electrons. Okay? Well, the easy way to fix having a little bit too many electrons when we only have a set number is we change a single bond to a double bond. What does that mean? That means instead of just sharing 2 electrons, the C and the O share 4 electrons. How can we do this? Well, very simple. Actually, I can erase. Very simple. We just add 1 line. So pretty much C equals O, C equals O. That's simple. What does that mean? But you have to remember, like they're sharing 2 extra electrons, you have to take 2 of these lone pairs out. Each one. So let me show you how this means. Okay. So the carbon is sharing 4 electrons, so double bond means it's going to share 4 electrons with the oxygen. That means the oxygen right now has 4. The carbon has 4 from this side. Now with the other oxygen, he's also sharing 4. So that's 4 and 4. That means the carbon has 8. Boom. That satisfies the Octet rule, which means every single molecule has to have 8 electrons. Every single atom, excuse me. Now, the oxygen has 4 from the double bond. This oxygen has 4 plus 2 lone pairs, which a lone pair, remember, is 2. A lone pair is 2 electrons. So 2, 4, 6, 2, 4 plus the 4 that is sharing with the carbon. That's 8. So boom, electron. The Octet rule is satisfied for this one. Then we're stuck here at this one. Has 2 sets of lone pairs. So 2 and 2, that's 4, plus the 4 that's sharing, boom, that's 8. Now let's make sure that everything adds up to 16. So we have 1, 2, 3, 4, 5, 6, 7, 8, 8. Now it's sharing 4 from this side, so that's 4 more. What's 8 times plus 4? Anyone? Right again, Jimmy. We're looking at 12, plus this oxygen sharing 4 with the carbon, so there's 16. So it meets the Octet rule for each atom has 8 electrons, and all the electrons add up to 16. Let's go over that again. This is a double bond, which means that the carbon and the oxygen are sharing 4 electrons. Okay? 4 electrons. So that means the carbon has 4 from this oxygen, and the oxygen has 4. Same thing with this. Carbon has 4 more. This oxygen has 4. Carbon has 8, plus 2 sets of lone pairs for each oxygen. That gives them 4 more, so 8, 8, and 8, and boom, you have your Octet rule satisfied.